Good morning. I'm going to present you a work on biofertilizer production through solid-state culture from forest litter in anaerobic conditions. I'd like to thank all the partners of this work, especially people from IMBE of Marseille University and Marseille University MIO, the association Terre and Humanisme, and the CIRAD and a Cuban partner. First, we can consider the loss in fertility of agricultural soils combined with the increasing population, world population there is a strong need to restore or maintain soil fertility through alternative techniques, such as fermented forest litter, a nature-based solution, cheap, low-tech, adapted to most of the world's regions, and developed especially in Southeast Asia and some Latin American countries. The present work is a case of reverse engineering. We begin from observations of a process that works, but it's a black box, and we are trying to give some answers what is going on during the process of fermentation, especially with a special focus on the role of oxygen. To prepare the fermented forest litter, first we go to collect some forest litter and mix it with substrates, agro-industrial substrates, such as wheat bran, whey for lactic acid bacteria, whey, molasse. We add water to get substrate sufficiently humidified to allow the growth of microorganisms. The blending is very important, and we fill vessels from 30 liters to 200 liters, and we pack it. Oh, excuse me. And we pack it to avoid oxygen during the process. 1 month later, we get the fermented product. The experimental condition in the lab was we made a mixture with white oak litter with bran, whey, molasse, and water in the proportion given here. 3 oxygen conditions were studied: 0, 0.5 intermediate condition, and 2% conditions. That's enough to get no oxygen limitation. The columns were filled with 100 grams of dry matter with a initial moisture of 35% and a gas flow rate of 0.1 liter per minute. Temperature is not controlled, it's lab temperature, and 21 days of culture. The analysis online with CPG, CO2 production, oxygen consumption, volatile organic compounds production with CPG and FID. Offline analysis at the end, at the beginning and the end of the process. These parameters that I will detail later. Sugar consumption and acid production were followed by HPLC, and microbial characterization by metabarcoding. This is a rapid reminder of the fermentations that can occur during the process. Lactic fermentation, homolactic or heterolactic. Homolactic only acid lactic. Lactic acid. Hetero can give ethanol and acetic acid. Alcoholic fermentation especially with yeast. And eventually acetic fermentation from ethanol to acetic acid with bacteria such as Acetobacter. The first parameters, the first results, we have here pointer. No. The first, here, the initial conditions, we have pH close to the neutrality, water activity to a low gross microorganism growth, electroconductivity, and moisture. At initial and first at 0% at in anaerobic conditions, the pH decrease, the EC, the electroconductivity decrease a little bit, and the moisture remain constant. The conditions of water, of oxygen with oxygen, the pH increase, we are in the conditions of composting. We have some physical-chemical parameters are describing the phenomenon here. We have the respirometric activity, oxygen at 0.5% of oxygen. All the oxygen fed is consumed. Here we can see that here we have no oxygen, this color, and here with 0.5 oxygen growth of fungi, and in this part, in the bottom of the second column also, and in oxygen at 2%, we have growth of fungi all in all the column. The maximum oxygen consumption when oxygen is not limiting is around 6 or 7 days. And for CO2 production, here, CO2 production is CO2 from a fermentation, sensu stricto. Here we have oxygen CO2 production with from respiration, and the highest peak is in the intermediary conditions. Excuse me. Here it's yes. Here is CO2 production from fermentation, intermediary, and with no oxygen limitation. Excuse me. Here we have the two volatile compounds we found was ethanol and ethyl acetate with FID detector. The more important concentration with ethanol and ethyl acetate coming from the esterification of acetic acid, 10 less concentration in the gas. More ethanol with intermediate conditions, and here from 0.0%, and the less in oxygen, no limitation of oxygen. The same pattern is observed for ethyl acetate. Well, yes. This is the balances of respirometry and VOC. I accelerate. For about sugar consumption and acid production, during the fermentation, we follow the disaccharides here, monosaccharides, and lactic and acetic acid production. In initial conditions, we have these concentrations. At 0%, all the disaccharides, in all the conditions, all the disaccharides are consumed, but in this condition, in anaerobiasis, after 3 weeks, some glucose and fructose was remaining. Lactic acid reaches highest concentration in this condition, but also acetic acid. In terms of microorganism characterization, a study of Alejandra Gutierrez in 19 on selected medium found that we have a strong influence of oxygen on mesophiles here, on fungi and yeast, a very low fungi yeast in anaerobic, but probably yeast as fungi can grow without oxygen. And lactic acid bacteria is impacted by the oxygen concentration here. No, in these conditions, no Staphylococcus, Clostridium, or Enterobacteria were found. And a study of metabarcoding here. This is the biodiversity, bacterium biodiversity at T0. And after 3 weeks, we can show that we can see that it was drastically reduced by the anaerobic conditions, and we found basically lactobacillus. The conclusions. We show the importance of oxygen in the process, in this empirical process. Maximum oxygen, maximum activity, microbial activity was around the 7th or 8th day of culture. Various fermentation are involved, homo and heterolactic, as we found acetic acid in the final product, and residual sugars at 0%. So we can think that we can last the fermentation 4 weeks instead of 3 weeks in these anaerobic conditions to avoid remaining sugars. Highest lactic condition ensures the stability of the products. We show that it was stable during 1, 2, and 3 years. Acetic acid probably comes from the heterolactic fermentation. And the importance of whey is to orientate the fermentation toward lactic fermentation. And for no pathogen were detected, it's very important for the future use in agriculture soils. And mesophiles and bacteria and fungi are predominant if oxygen is in small or high amounts. Thank you very much. I apologize for the for the error. I want to